Now we have learned converse of BPT. Let's do another sum based on converse of BPT so that it is very clear how to apply that, right? It says here we have a triangle given to us and we have that EF is drawn. We have few lengths given to us. We need to identify, check whether EF is parallel to QR, right? First we have P to be 4, we have QE to be 4.5 centimeter. The length of PF is given as 8 centimeter, length of RF is given as 9 centimeter, right? And we need to check whether EF is parallel to QR. Now if we prove that PE upon EQ, this ratio is equal to PF upon FR, then can we say that EF is parallel to QR? Yes, we can say that. That means the hint is we just need to check whether PE upon EQ is equal to PF upon FR. That's our job. So let's find one ratio. The first one. Let's find PE upon EQ. Now when we are going to find P upon EQ, do we know the value of P? Yes. Do we know the value of EQ? Yes. Let's substitute it. The value of P is nothing but we have it as 4 and the value of EQ is nothing but it is 4.5. So we substitute that. Now to remove the decimal, we'll multiply and divide by 10. So we'll get it as 40 upon 45, right? And when we do the cancellation, we will get it as 5 8s are 40, 5 9s are. So we have the ratio as 8 upon 9. Now this is what we have. So that means we got the first ratio. P upon EQ is equal to 8 upon 9, which will be our statement number 1. Let's take the next one now. That is PF upon FR. For that, we substitute the value of PF. We know the value of PF is nothing but 8. And the value of FR is nothing but it is 9. Substitute that. There is no cancellation to be done. That means this ratio is 8 upon 9. What do we observe from 1 and 2? The ratios are equal. That means we can say that in this triangle PQR, we have that PE upon EQ is equal to that PF upon FR. Right? That means we can say that EF is parallel to QR and the reason is by converse of basic proportionality theorem. So you understood ratio is equal, that is the line is parallel to a side. Let's do one more sum based on the same concept. It's again interesting. So we have this figure, the values are given. Let's check which are the values given. PQ is 1.28, we have the value of PR as 2.56, the value of PE is 0.18, the value of PF is 0.36. Again we know that if we prove PE upon EQ is equal to PF upon FR, can we say EF is parallel to QR? Yes, that means we need to just check whether PE upon EQ is equal to PF upon FR. So let's start finding the first ratio, that is PE upon EQ, right? Now for PE upon EQ, let's substitute the value of PE. Do we know the value of PE? Yes. How much is that? It is 0.18. We substitute that value there. What is the value of EQ? EQ, we don't know. EQ, no, we don't know. So the question is, how will you find EQ? Let's understand. Now EQ is nothing but it is very simple. It will be PQ minus PE. And we have the value of PQ. What's the value of PQ? It's nothing but 1.28. And what is the value of PE? It is nothing but we have it as 0.18. So substitute the value there. So 1.28 minus 0.18 and we get the value of EQ as 1.10. Right? Now we substituted there. So we will have PE upon EQ is equal to 0.18 upon 1.10. Now there are two decimals to be removed, two decimal places, right? So multiply and divide by 100. So we'll have it as 18 upon 110. Now do the cancellation. We'll have it as 2 9s are 18 and 2 55s are. That means we get the ratio of PE upon EQ as 9 upon 55, which will be our statement number 1. Now we do the next, that is PF upon FR. Let's do the same way, very simple. Right, the value of PF we know is nothing but 0.36, right? We substitute there. The value of FR not known to us, but can we find it? Yes, we know how we are going to find FR. FR is nothing but it is PR minus PF. The value of PR is known to us. How much is that? That is 2.56, and the value of PF is known to us as 0.36. So we subtract it now. So we get the value of FR to be 2.20. Now we substitute there. So we get PF upon FR is equal to 0.36 upon 2.20. 2 decimal places you need to remove. So multiply and divide by 100. We'll get it as 36 upon 220. Now do the cancellation there. So we'll get it by cancelled by 4 9s and 455s. That means we get the ratio of PF upon FR also to be 9/25. Now from 1 and 2, what do we understand? The right hand sides are equal. That means we can say that PE upon EQ, that ratio is equal to PF upon FR, this ratio. That means we can say right now, since the ratios are equal, that means EF is parallel to QR. And the reason for that would be nothing but by converse of basic proportionality theorem. Wasn't that easy?